What you'll see on the left is a histogram of all of our reported sightings as a function of altitude. So most of our sightings occur in the 15 to 25,000 foot range, and that is ultimately because that's where a lot of our aircraft are. On the far right upper corner, you'll see a breakout of the morphologies of all of the UAP that are reported. Over half, about 52% of what's been reported to us, are round orb spheres. The rest of those break out into all kinds of different other shapes. The gray box is essentially there's no data on what its shape is. Either it wasn't reported or the sensor did not collect it. The bottom map is a heat map of all reporting areas across the globe that we have available to us. What you'll notice is that there is a heavy, what we call collection bias, both in altitude and in geographic location. That's where all of our sensors exist. That's where our training ranges are, that's where our operational ranges are, that's where all of our platforms are. In the middle, what we have done is reduce the most typically reported UAP characteristics to these fields, mostly round, mostly 1 to 4 meters, white, silver, translucent, metallic, 10,000 to 30,000 feet, with apparent velocities from stationary to Mach 2. No thermal exhausts usually detected. We get intermittent radar returns, we get intermittent radio returns, and we get intermittent thermal signatures. That's what we're looking for and trying to understand what that is. Next slide. So I'm going to walk you through 2 cases that we've declassified recently. This first one is an MQ-9 in the Middle East, observing that blow up, which is an apparent spherical object via EO sensors. Those are not IR. If you want to go ahead and click that and play it, you'll see it come through the top of the screen. There it goes, and then the camera will slew to follow it. You'll see it pop in and out of the field of view there. This is essentially all of the data we have associated with this event from some years ago. It is going to be virtually impossible to fully identify that just based off of that video. Now, what we can do and what we are doing is keeping that as part of that group of 52% to see what are the similarities, what are the trends across all of these, do we see these in a particular distribution, do they all behave the same or not? As we get more data, we will be able to go back and look at these in a fuller context. How are we going to get more data? We are working with the Joint Staff to issue guidance to all the services and commands that will then establish what are the reporting requirements, the timeliness, and all of the data that is required to be delivered to us and retained from all of the associated sensors. That historically hasn't been the case, and it's been happenstance that data has been collected. Next slide. This particular event, South Asia MQ-9, looking at another MQ-9, and what's highlighted there in that red circle is an object that flies through the screen. Unlike the previous one, this one actually shows some really interesting things that everyone thought was truly anomalous to start with. First of all, it's a high-speed object that's flying in the field of regard of 2 MQ-9s. Second, it appears to have this trail behind it. All right, which at first blush you would think that looks like a propulsion trail. In reality, if you want to play the first slide, we'll show you what that looks like in real time, our first video. So we're looking at that, there it goes. Why don't you play it again and then pause it halfway through? Right there. All right, if you might be able to see that trail there behind it. That's actually not a real trail. That is a sensor artifact each one of those little blobs is actually a representation of the object as it's moving through. And later in the video, as the camera slews, that trail actually follows the direction of the camera, not the direction of the object. We pulled these apart frame by frame. We were able to demonstrate that that is essentially a readout overlap of the image. It's a shadow image, right? It's not real. Further, if you later follow this all the way to end, it starts to resolve itself into that blob that's in that picture in the top left, right? And if you squint, it looks like an aircraft because it actually turns out to be an aircraft. Go ahead and put that on. So you'll see the tail sort of pop out there. And so what you're looking at is, this is in the infrared, this is the heat signature off of the engines of a commuter aircraft that happened to be flying in the vicinity of where those two MQ-9s were at. Why am I showing you this? So the first one that I showed you, we don't have resolved yet, right? That is an unresolved case we are still studying. This one we can resolve, but this is the kind of data that we have to work with and the type of analysis that we have to do, which can be quite extensive when you have to pull these apart frame by frame. Further, we're now matching all of this with the models of all of those imaging sensors so that I can say, I can recreate this. I can actually show how the sensor is going to respond. All of these sensors don't necessarily respond the way you think they do, especially out in the world and in the field. And I believe that's all I have, and I will open it up for your questions.
Thank you so much, Dr. Kirkpatrick. Can you just give us some raw numbers of how many UAPs you've analyzed, how many have been resolved, and sort of in what buckets, and then how many are still left to be resolved? Just an update from your January public report where it was 366 or something, and about 150 were balloons and about 24 were drones. You know, just give us an update if you have one.
Sure. So as of this week, we are tracking over a total of 650 cases. Now, the report in January basically said about half of the ones at that time, about 150, were likely balloon-like or something like that. Mm-hmm. That doesn't mean they're resolved. Oh, I see. Okay, so what? Let me walk everyone through what our analytic process looks like. We have essentially a 5-step process, right? So we get our cases in with all the data. We create a case for that event. My team does a preliminary scrub of all of those cases as they come in, just to sort out, do we have any information that says this is in one of those likely categories? It's likely a balloon, it's likely a bird, it's likely some other object. Or we don't know. Then we prioritize those based off of where they are. Are they attached to a national security area? Does it show some anomalous phenomenology that is of interest? If it's just a spherical thing that's floating around with the wind and it has no payload on it, that's going to be less important than something that has a payload on it, which will be less important than something that's maneuvering, right? So there's sort of a hierarchy of just binning the priorities because we can't do all of them at once. Once we do that and we prioritize them, when we take that package of data in that case, and I have set up 2 teams, think of this as a red team, blue team, or a competitive analysis. I have an intelligence community team made up of intelligence analysts, and I have an S&T team made up of scientists and engineers and the people that actually build a lot of these sensors, or physicists, because, you know, if you're a physicist, you can do anything, right? But they're not associated with the intel community. They're not intel officers. So they look at this through the lens of the sensor, of what the data says. We give that package to both teams. The intelligence community is going to look at it through the lens of the intelligence record and what they assess, and their intel tradecraft, which they have very specific rules and regulations on how they do that. Scientific community, technical community is going to look at it through the lens of what is the data telling me? What is the sensor doing? What would I expect a sensor response to be? And back that out. Those two groups give us their answers. We then adjudicate. If they agree, then I am more likely to close that case if they agree on what it is. If they disagree, we will have an adjudication. We'll bring them together, we'll take a look at the differences, we'll adjudicate why do you say one thing and you say another. We will then come to a case recommendation. That'll get written up by my team. That then goes to a senior technical advisory group, which is outside of all of those people, made up of senior technical folks and intel analysts and operators from retired out of the community. And they essentially peer review what that case recommendation is. They write their recommendations. That comes back to me. I review it. We make a determination, and I'll sign off one way or the other. And then that will go out as the case determination. Once we have an approved web portal to hang the unclassified stuff, we would downgrade and declassify things and put it out there. In the meantime, we're putting a lot of these on our classified web portal, where we can then collaborate with the rest of the community so they can see what's going on. That's, in a nutshell, that is the process, right? So because of that takes time. So of those over 650, we've prioritized about half of them to be of anomalous, interesting value. And now we have to go through those and go, how much do I have actual data for? Because if all I have is a operator report that says I saw X, Y, or Z, my assessment is A, B, or C, that's not really sufficient. That's a good place to start, but I have to have data. I have to have radar data, I have to have EO data, I have to have thermal data, I have to have overhead data, and we need to look at all that. Now, from a big picture perspective, I still have, that's all still very valuable data. And we're looking at applying a lot of things, new tools, analytic tools like natural language processing. So I can go across all of those reports and look for commonalities. How many of them are being described as round spherical objects that are maneuvering? How many of them are not maneuvering? How many of them seem to have a plume to it or note? That's also going to be very valuable to give us more of a global picture and a trends analysis of what are we seeing, right? And help us get to the determination. So go back to your question, ma'am. We have this next quarterly report will be coming out here pretty soon. Our next annual report, you all have given us, moved it up to June, July. We're going to be having that done about that time frame, and we will have we'll be combining a whole number of reports into that one. I think we're currently sitting at around, if I remember correctly, we're around 20 to 30-ish are about halfway through that analytic process. A handful of them have made it all the way out to the other side, gone through peer review. We've got case closure reports done and signed. We're going to get faster as we get more people on board and we get more of the community tools to automate some of the analysis that has to be done.